day, sir. So today I will tackle three different discussion. It is the validity of the argument, circuit diagram, and the Euler diagram. So first, I will start with the circuit diagram. I already write the problem that I made myself. I made nine switches. One, two, three, four, five, six, seven, eight, nine. So let's solve them together. Uh, since I write the problem on the board, I will write the tables in my scratch paper. So let's start. So let's start by writing this diagram into a formula. So I will start here until it connects over here. So let's start. This can be read as R or P since it is written with OR gates. So let's write that. R or P. Then and Q since it is written in straight line and negation of Q rather and negation of Q and P and negation of Q and P. Then OR since it is going down way. So OR negation of Q and negation of Q and R and negation of Q, R and negation of Q, or since it's in the bottom, or P and negation of R, P and negation of R. So let's group it here, and one here, and one here, and one here. Also, let's do this, and then this side. So then we will write the constant variable, which is the P, Q, and R. So always remember that these are the constant or it will never change since this dictates the different combination of ons and offs switch. So we write 1 as on and 0 as off. So it would be 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So the next thing we'll do is to find the negations. We can see from the diagram is the negation of Q and negation of R. There is no negation of V, so we won't write that. So to get the negation of Q and negation of R, the negation of Q, we will look at the Q and do the opposite. So if it states 1, then we will write 0, and if it states 0, then we will use the 1. So it will be 0, 0, 1, 1, 0, 0, 1, 1. Same with the R. We will negate this R over here. So it will be 0, 1, 0, 1, 0, 1, 0, 1. Then the next step is we will start on solving this slowly. So the first one is the R or P. R or P. To get the R or P, if there is 1 in between R or P, then it would be also 1. But if there is no 1, then it will be automatically 0. So first, let's find the 2, 0, which make this statement an off switch. So it would be here 0 and 0. So we will write that, and the rest is 1. 1, 2, 3, 4, 5, 6, 7, 8. So the next one is negation of Q and P. Negation of Q and P. Now let's look between the negation of Q and P. So the criteria for this to be an on switch or the 1, it should be right within 1 here and 1 also here. So we can see that the third and the fourth switch fits the criteria. So that's the only time we will use 1. Otherwise, these are all zeros. Then next, let's compare these two. So their sign is and. So we first will write the complete part of this. So it will be R or P and negation of Q. And to get that, we will look at the R or P and the negation of Q and P. So since the sign is N, they should have both ones to get the 1. So it would be 0, 0, and 1. The rest is 0 since they don't have a 1 and 1 combination. Okay. So in this first part, the answer is this. Now let's move on to the second part. So since there is already a negation of Q, we don't need to solve that. So let's move on to the next one, which is the R and negation of Q. Let's write that. Uh, let's write that over here. R and negation of Q. Then the next one from the formula, R and negation of Q. Next one is P and negation of R. P and negation of R. So let's answer that first. The R and negation of Q is here. R and negation of Q. We should both have 1 to have a 1. So that criteria only meets these two. The third and the second to the last. So it will be written like this. 0, 0, 1, 0, 0, 0, 1, 0. So the next one is P and negation of R, negation of R. P and negation of R. So the sign is still N, so let's find two combination of ones. P and negation of R. So it will be 0, 1, 0, 3, 4, 1, and there's 0, 2, 3, 4. Next, we combine this two. There, according to the formula, their sign is OR. So it's because R and negation Q or P and negation R. So if we see 1, then it will be automatically 1. So this will 0, 0, 1, 1, 1, 0, 0, 1, 0. Okay. Comparing this and the negation of Q. So we will write it as negation of Q, which is the negation of Q, and R, and negation of Q, or P, and negation of R. So we already answered this. We will only compare this to negation of Q and this. So the 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0. So for the last part, we will complete this. We will complete this one. So their sign, let's rewrite it first. I will continue this here because it has a larger space, so it will be. So now let's compare these two. Their sign is OR, so if there is 1 in them, then it will be automatically 1. So the answer, final answer will be 0, 0, 1, 1, 0, 0, 1, 0. This is the final answer. So let's construct the sentence. So this case will only be on if in the second, the third, fourth, and the second to the last, which is when the third one is when the P is on, Q is off, and R is on. P is on, P is on, Q is off, and R is on. Then the next case is when the P is on, Q is off, and R is off. So P is on, Q is off, and R is off. The last one is when the P is off, Q is off, and R is on. P is off, Q is off, and R is on. So let's check that. So when P is on, we will write it as on. So this is the time when the electricity will go over here. Q is off. That means the negation of Q is on, so it will also be on. So the electricity can go over here, and R is on, so it will be also on here, so it could arrive on the light perfectly. So P is on and R is on. Negation of Q is off, so there its negation is on, so it could travel here. Next scenario is when P is on, Q is off, and R is off. Q is off, it will be on, R is off. The electricity won't go here, so let's assume that the electricity run here. Q is off, so negation of Q is on, R is off, so it won't go over here. But it can go here since P is on and R is off. That's why the negation of R is on, so that the electricity can travel over here to go to the light, since this negation of Q is off is on, P is on, and negation of R is on since the R is off. The third scenario is when the P is off. P is off, so it won't travel here. So let's assume the electricity travels here. P is off, so and Q is on, so negation of the Q is off, so the negation of Q is on. Then R is on, so it could travel again here. Then Q is off, so the negation of Q is on, so the electricity can travel here. So I'll explain it again. The Q is off, so this both negation of Q is on, and the R is on, so it will fully be automatically reach here. So let's give an example from this. It is said that this won't work if the first statement is true. So let's check that. So it is when PQR is on. So if this is on, the Q is on, so the negation of Q is off. So the electricity here will be cut off. Same here. So if Q is on, then the negation of Q is off. So it is uh, not doable. So these are the only three cases where we will have an on output, while the other cases gives an off output. So the next one that I'm gonna discuss is the evaluation of the validity of an argument. So like the last one, I also wrote my variables on the board with the different kinds of reasoning, and I will give an example in each of them, and I will make my own one argument and prove it if it's valid or not. So let's start. So my three variables are: for P, I have my own business; Q, I am rich; R, I am happy. So I will give example from each of them. Then I will construct one more complicated reasoning, and I will apply this to prove that the sentence that I made is valid or invalid. I will also show you table to prove it. So for direct reasoning, we can say if P then Q. So P therefore Q. So if P then Q is if I have my own business, then I am rich. I have my own business, therefore I am rich. P therefore Q. That's my first example. The other one is contrapositive reasoning. So if P, then Q. If I have my own money, then I am rich. So if we negate them, it would be if I am not rich, therefore I don't have my own business. For transitive reasoning, would be if P then Q, so I have my own business, then I am rich. So if Q then R, therefore P, if P then R. So we will read it as if I am rich, then I am happy. Therefore, I have my own business. Therefore, I am happy. For disjunctive reasoning, it is P or Q. So I have my own business or I am rich. So it would be negation of P, therefore Q. So I have I do not have my own business, therefore I am rich. So let's prove this one by one with truth table. So let's always write the P and Q for this both reasoning since it only apply P and Q. Let's write it. Uh, P and Q are are constant. Then our first statement is P and Q. The second statement is P, and the conclusion is Q. So the first statement is P, then Q, second is P, and the conclusion is Q. So let's write the constant. Where's the F, F, the F, the F. The next, if P then Q, the reasoning will only be false if the first one is true and the second one is false. So this would be otherwise this is true. So this is false and the others is true. Let's copy P and Q since it's already given. F, P, F, P, F. So we will only look from this tree or the given formula. The first we should find that the first and second should have, if both of them are T, then the conclusion should be T. So we can observe that here. So we can say that the statement, the reasoning is valid. So for contrastive reasoning, uh, same here. We will also be using this P and Q. If P and Q, then negation of P, therefore negation of Q. So let's write the constant P and Q, P, D, F, F, P, F, P, F. If P then Q, then the negation of Q and the negation of P, the conclusion. The first, the second, and the conclusion. So if P then Q, same answer as here. P, F, P, F. Then we will negate the Q by writing the opposite of the Q. So this would be F, P, F, P. Then here we will also negate the P, so this would be F, F, P. So if the first statement and statement is true, the conclusion should be true. So we can observe that here. So the statement is also valid. Then the next one is the transitive reasoning. So if P, then Q, Q, if Q, then R, therefore P, if P, then R. So we will write that in the table also. So we have three given variables. So P, Q, and R, we will write their constant. Then if P then Q, the first statement, then if Q then R, Q then R, therefore the conclusion is P, if P then R. So let's look at it. The first state the first one should be not true. It could be true, but the second, if it's the first statement is true, the second one shouldn't be false. So if that happens, then the statement is false. So let's look on where that applies around here. So these are false, and the otherwise these are true. Same here, Q and R. We will look at this. This is false, and this is also false. Otherwise, these are true. P then R. We will look at the problem. P then R around here again. Otherwise, it is true. So we will can observe that the first and the second, if the first and second statement is true, then the conclusion should be true. So we can insert it here, also here, and here. So there are nothing wrong with it. So therefore, we can conclude that the statement is valid. So the last one is the disjunctive reasoning. So P or Q, not division of P, therefore Q. So we can write this C, Q, P or Q, division of P, therefore Q. So P F, P F, then P or Q, if one of them is true, then it will be automatically true. This is false because this is both false. So we will delete the P, it will be F, F, T, T, then we will copy the Q, which is T, F, T, F. So we can see that there is 3T here and no TTF, so this statement is valid. Now, aside from that, I will also give another example, the statement that I construct myself. So, uh, let's say that if P then Q, from the statement, if P then Q, if P then Q, so Q or R, therefore Q or P. So we can write that if P then Q, if if I have my own business, then I am rich, then I am rich, or I am happy, therefore I am rich, or I have my own business. So we will write this. Since there are three variables, we will going to use that table. So P Q R F F F D D F F D D F F D F D F D F D F. And the first argument is if P then Q. The second argument is Q or R. Therefore, the conclusion is Q or P. So this would be P then Q. If there is a case where the first one is T and the second one is false, it will be automatically false. Otherwise, true. For Q and R, we only want, we're looking for one. So if Q or R, we will be looking for one T. So if there is, then it will also immediately become T. So Q or R. So all of them are true except for this. And this one will be false. Otherwise, no. Then Q and R, the same criteria. Q, no. Q and P, so Q and P. So there is two cases that both false, so it will be false. Otherwise, it will be true. So we can observe that this is good. This one also. So if I have my own business, then I am rich. QRR, I am rich or I am happy. Therefore QNP, I am rich. No, QRP, I am rich or I have my own business is valid statement according to the truth table. So the last one that I'm going to explain is the Euler diagram. So I already wrote my four valid statements and I'm going to explain it to you how is it valid, and I also made one more complicated statement and I will explain it to you and do the diagram with you so I can prove it further and explain how that doing this diagram can make you determine if the statement is valid or not. So let's go. So my first statement is all girls are loyal. So when doing Euler diagram, you will represent this variable using circle. So we have the variable here which is girl and loyal. So this is the all girls are loyal. So this example is the girls and this is the loyal. So this statement is valid since all girls are loyal. It is inside the L or the loyal circle. Next one is some boys are loyal. This is boys and this is loyal. Some boys are loyal is correct since the boys and loyal circle is overlapping. Next one is no boys are loyal. No boys, so no, that means they are not connected. B and L is not connected. So since the it is not connected, then the no boys are loyal is valid. Also, some boys are not loyal, so they would write draw it as some, so they will be interconnected somehow. But boys are not some boys are not loyal, so that means your subject is here, so which makes this statement valid since the Euler diagram shows that it is possible. So I will give you one more explanation here to make it work and to show you how important doing the Euler diagram to make the sentence more easier to understand. So no cigarettes are healthy. That means it is not connected. No, because there is a word no. No cigarettes are healthy. So example, this is cigarette and this is healthy. We can say that no cigarettes are healthy since it's not cigarette. No, this is not connected. Then while all vegetables are healthy, so this is the healthy, so it is said that all vegetables are healthy, so let's just say this is vegetable, so we can say that all vegetables are healthy since it is inside the healthy diagram. So we can conclude that no veggies are cigarette. So this is the subject, the veggies. So no veggies are cigarette. We can say that this statement is valid since the veggies and cigarette doesn't interlock. So that's all for today's video. Thank you guys for listening and see you guys next time. Bye.